We have learned from previous video we can use TensorFlow library to build a single layer. In this video, we will stack multiple layers together. In deep learning, stacking multiple dense layers together forms a deep neural network. This structure is important and often leads to better performance because it allows the model to learn more complex patterns and representations in the data. Let's think of it in terms of a real-world example. Imagine you're trying to recognize objects in images. A single layer might be able to recognize simple patterns, like lines or edges. But recognizing an object like a car or a face involves much more complex patterns. You need to understand how lines and edges come together to form shapes, how those shapes form parts of an object, and how those parts come together to form the whole object. This is where multiple layers come in. The first layer might learn to recognize lines and edges. The next layer can take the output of the first layer and learn to recognize shapes. The layer after that can recognize parts of objects, and so on. Each layer builds on the outputs of the previous layer, allowing the model to learn increasingly complex representations. This ability to learn hierarchical representations is one of the key reasons why deep learning models have been so successful in tasks like image and speech recognition. However, it's worth noting that adding more layers also makes the model more complex and can make it harder to train effectively. It's always a balance between model complexity and performance. In this code, we're using TensorFlow, a powerful tool for machine learning, to create a more complex model than before. This model is a type of artificial neural network, which is a computing system inspired by the human brain. It's made up of layers of nodes, or neurons, each of which performs a simple computation on the data. The tf.keras sequential function is used to create a model that consists of a linear stack of layers. You can think of this as a pipeline. Data enters at the first layer, and the output from each layer is fed into the next. Inside the brackets of tf.keras sequential, we define the architecture of our model. In this case, we're adding 3 layers to our model using tf.keras.layers, dense. The dense layer is a standard layer type that works by connecting each input to each output within its layer. It's the most common and frequently used layer. The units equals 5 argument in the first 2 layers means that these layers will each have 5 neurons. The more neurons a layer has, the more patterns it can learn from the data. The activation equals relu argument refers to the activation function that's used to transform the outputs of the neurons in these layers. Relu stands for rectified linear unit, which is a simple function that allows the neuron to output the input directly if it is positive, otherwise, it will output 0. The final layer has units equals 1, meaning it has 1 neuron. This is the output layer of the model, and its job is to take the high-level representations learned by the previous layers and turn them into a final prediction. In essence, this code is creating a neural network with 2 hidden layers, each with 5 neurons, and an output layer with 1 neuron. This network would be capable of learning much more complex patterns in the data compared to a single-layer network.